Greetings and welcome to the xTech Inversion Informational webinar. My name is Gia Hester and I'll be the moderator for today's session. Next slide, please. During this webinar, participants will have the opportunity to hear from myself, as well as the initiative lead and Army inventors and subject matter experts for IP sets for this competition. Today's session will be recorded and distributed to those who have registered for today's webinar via your email address after the conclusion of the session. Questions for this session were received in advance of today's program and will be answered by myself and subject matter experts on today's call. If you have any questions after today's webinar, please feel free to reach out to the xTech team via email. Next slide. And I'd like to take a few minutes to provide an overview of the Army FUZE xTech program. Next slide. The Army FUZE xTech program is the Army's premier mechanism for scouting and accelerating dual-use technologies that strengthen soldier readiness and mission success. Operating within the U.S. Army Pathway for Innovation and Technology, known as the PIT, xTech provides a disciplined, repeatable process for sourcing emerging capabilities and aligning them with validated operational requirements. Through competitions and targeted prize challenges, xTech enables the Army to assess solutions early, engage inventors who may not traditionally work with the Department of War, and reduce barriers to entry for companies with relevant technologies. This approach broadens the Army's reach into commercially developed innovation and increases the pool of viable solutions available to operational stakeholders. Competitions are structured to move beyond concept evaluation and into practical assessment, enabling innovators to demonstrate performance in environments that reflect real mission conditions. By progressing solutions from white paper review to live soldier touchpoints, xTech helps the Army screen solutions at scale while reducing technical, integration, and transition risks prior to acquisition decisions. Next slide. The Army is investing in cutting-edge technologies that solve real-world problems through the xTech and CyberSitter programs. The xTech program manages the Army's prize competitions to discover, award, and accelerate innovative technology solutions from non-traditional entities to bridge the gap between emerging technologies and critical military needs. The Army Small Business Innovation Research and the Small Business Technology Transfer programs align innovative small businesses with critical U.S. Army priorities to turn over game-changing solutions to our most critical customer, the soldier. The Army Small Business Innovation Research Program, known as CIBR, helps businesses overcome the inherent challenges to working in government research and development. CIBR fosters collaboration and connects companies with soldiers and Army technical and subject matter experts to accelerate development of innovative technologies that address defense challenges. And the Army Small Business Technology Transfer Program, known as CITR, is a sister program to Army CIBR. While CITR is like Army CIBR in its partnership to integrate small businesses into the Army space, here, the small businesses partner with a university, federally funded research and development center, or a qualified nonprofit research institution as part of their contract. xTech frequently partners with the Army CIBR program to provide competition winners with additional opportunities to complete for follow-on CIBR contracts. The Army CyberSitter program focuses on transitioning technologies into the hands of the soldier. Structured to align with critical Army priorities, each Army CIBR project provides various opportunities for companies to enter and transition at different phases. The program aims for a clear understanding of the Army's technology needs and acquisition strategy early on to ensure timely and successful integration into fielded systems. The Army has been incorporating lessons from the private sector and the xTech program to improve the Army CyberSitter program operations, aiming to make it easier for businesses to work with the Army and tap into innovative solutions. A few differences between the two programs is that xTech provides non-dilutive cash prizes through competitions, while Army CIBR offers contract awards. xTech focuses on broadening the funnel of innovators collaborating with the Army, while Army Cyber concentrates on transitioning technologies into soldier use. The synergy between the xTech and Army Cyber programs offers a clear roadmap for small businesses to enter the defense market. The Army is the only service maximizing the prize authority statute by offering non-dilutive funding through xTech cash prizes and then follow on Army Cyber contract awards. This provides incentives to businesses, a pathway for vendors to continue their work with the Army, and an opportunity to drive towards transition. These programs are breaking down barriers so that you, the small business, have the opportunity in collaborating with the Army. Next slide. Since 2018, xTech has executed more than 50 competitions that have partnered non-traditional entities with DOW partners, received over 9,000 submissions from around the world. Also noting that 46% of our applicants are new to the DOW, so you do not need to be a part of the DOW ecosystem to be a part of the xTech program. Awarded over $29 million in cash awards, as well as over $258 million in follow-on Army Cyber contracts. So the xTech program clearly shows how xTech competitions are the friendly front door for innovators. Next slide. Now we'll take a look into the xTech Inversion competition components. Next slide. Thank you. xTech Inversion is seeking information from eligible small businesses across the U.S. to identify and advance commercialization pathways for a curated portfolio of high potential Army intellectual property sets. So we're flipping the script on how the Army hosts prize competitions, where instead of asking industry to showcase their technologies, we are providing industry with high potential Army patents and asking participants to present their commercialization and feasibility plans for advancing these Army developed technologies. xTech Inversion will consist of 2 key phases with follow-on opportunities. In the Part 1 concept white paper phase, which is currently open and accepting submissions until June 30th, all eligible entities should submit up to a 5-page concept white paper, clearly outlining their technical concept and innovation, commercial viability, market potential, execution, and Army alignment. This information is found in the evaluation criteria that you will see later in this presentation and on the Valid Eval sign-up page. After the submission window closes, a panel of Army and DOW subject matter experts, including inventors, will evaluate the proposal submissions against the evaluation criteria and select up to 12 finalists who will receive a prize award of $20,000 each and advance to the Part 2 finals event. Finalists will have the opportunity to participate in the xTech Inversion Finalist Accelerator, a cohort-based program providing educational programming, community building, mentorship, and strategic exposure. For the Part 2 finals event phase, finalists will conduct an in-person pitch of their solution to a panel of Army and DOW experts at or around Fed Supernova in Austin, Texas from August 18th through 20th, 2026. Up to five final winners will be selected and each receive a prize award of $152,000 and an opportunity to submit a Phase 1 cyber proposal worth up to $300,000 each. Additionally, winners will have the opportunity to participate in the xTech Inversion Winner Accelerator, which further expands on the finalist accelerator. For more information regarding the in-person finals event and detailed instructions to submit the Army Cyber proposal materials will be provided to selected participants. Next slide. As mentioned, in addition to the prize money, finalists and winners will have the opportunity to participate in the xTech Inversion Accelerator. This program is designed to help develop participants through educational programming, mentorship, venture building consulting, community building, and strategic exposure. As you can see here, the accelerator is designed to provide custom virtual webinars to help broaden participants' knowledge base, specifically in Army and DOW needs. the acquisitions process, and how the Army integrates with the defense industrial base. Participants will be given opportunities to build relationship with other participants in the accelerator and mentors within the DOW. Participants will also be given guidance on how to identify relevant stakeholders across the Army and DOW and how these stakeholders integrate new technologies across their programs. Next slide. So who is eligible to participate in this competition? This competition requires applicants to meet specific requirements in order to be eligible to participate. Participants should be small independent U.S. businesses, and applicants must own and control more than 50% of the firm's equity, which must be directly owned and controlled by one or more individuals who are U.S. citizens and or other for-profit small business concerns. Firms must not have more than 500 employees, and proposals must not be substantially the same as another proposal that was funded, is now being funded, or is pending contract award with another federal agency. Additionally, if you are selected as a final winner of the competition to submit Army Cyber proposal materials under this topic, your R&D work must be performed in the U.S. The principal investigator must be primarily employed by the small business, and the small business must perform at least 2/3 of the work for the phase 1. Next slide. All concept white paper submissions for this competition must adhere to the following. All applicants must utilize the concept white paper template located in valid eval sign-up page. All white paper submissions must not exceed the 5-page limit, as a 6-page or more submission will be disqualified. So please make sure you stay within that 5-page limit. Please also make sure you are adhering to the instructions of the white paper template to make sure you're abiding by the requested information, which includes listing the company name and proposal exactly how you would like them to appear on any contest marketing materials. This template should only be used for your submission, as this is a requirement. Only one submission per IP set per eligible entity is permitted. If submitting an application to more than one IP set, the technology solution must be different. All applications are due by 5 p.m. Eastern Time on Tuesday, June 30th, 2026. So please do not miss this deadline, as we will not be accepting any submissions after this time. So please think about submitting your application well in advance. That way, if you experience any technical difficulties, you have time to reach out to the xTech team so we can assist. Once again, please make sure you adhere to the instructions on the concept white paper for your submission, as you do not want to receive an email that your submission is invalid because you did not utilize the template found in the valid eval sign-up page. Next slide. Submissions for this competition will be evaluated and ranked utilizing the evaluation criteria provided on the valid eval sign-up page. On the screen, you will see the evaluation criteria at a high level. In the valid eval sign-up page, you will be able to find the descriptions for the various dimensions and subdimensions in which applicants will be evaluated on. So please review the evaluation criteria, and if you have any questions, please feel free to reach out to the xTech mailbox. For this competition, you will be evaluated on your technical concept and innovation, which will be 34% of your submitted proposal, commercial viability and market potential at 39%, and team execution and Army alignment at 24%, and proposal quality at 3%. The evaluation criteria is also outlined in the white paper template, which should be easy to follow along. Next slide. And next slide. At this time, I would like to introduce the initiative lead for this competition, Mr. Sam Klingsborn, with the Office of the Deputy Undersecretary of the Army, to provide some background on the competition initiative. Over to you, sir.
Thank you, Gia, and good afternoon, everybody. My name is Sam Klingsborn. I'm the Special Assistant to the Deputy Undersecretary of the Army, Mr. David Fitzgerald. First of all, I want to thank everybody for being at this webinar and for your interest so far as we just launched last week. To give a little bit of background, there's been a big push up here, specifically in this office, to accelerate technology transition within the Army. Specifically, there's a lot of great things going on in the labs, and that's something that Mr. Fitzgerald identified a few months ago. So the whole idea with this competition is to accelerate that. To name a few points, and I'll keep this very short so we can get to the Q&A, but to name a few points, the whole idea here is to overcome some of those traditional barriers and streamline the traditional process that we do technology transfer. Another one, foster dual use innovation, as you've seen, in the products that have come out regarding this competition. That's essentially the whole idea. Also, engaging non-traditional partners, that's something that the Secretary himself has really pushed over the last year and a half or so. So this competition directly gets after that. And then finally, of course, at the end of the day, this is all about enhancing our military capabilities and specifically aligning with identified capability gaps that we have. Gia, that's all I have if you want to get to the Q&A.
Thank you, sir. So the IP, if you can go back one slide, please. So the IP sets for this competition are currently on the screen for your reference. Rather than walking through each one, we want to dedicate this session to addressing the questions we received in advance, ensuring we maximize our time together. So next slide, please. This will conclude our presentation, and we'll move directly into the Q&A portion of this session. So the first question that I will ask to Mr. Klingsborn, in Inversion, is the intent to reverse operational assumptions, counter adversary, oh my gosh, pardon me, adversary, I cannot say the word today, system architectures, or restructure decision and data representation layers? And I'll pass the floor over to you, Mr. Klingsborn.
Thank you, Gia. I'll address this one in three parts. So for the first part, reversing operational assumptions, I think with this competition, it's really a strategic shift. So instead of the traditional pull for custom-built designs from private industry, we are trying to push our existing intellectual property that we've developed inside the labs out to industry to develop a commercialization plan. For the second part, as I said in the opening, I think at the end of the day, the true benefit to this is enhancing military capabilities, and what comes along with that is countering adversary system architectures. But really, it's more of an agnostic and secondary benefit to this whole thing, because we really want to increase technology transition from the labs and increase those relationships with some non-traditional partners. And then finally, restructuring the decision and data representation layers. With that one, I think, again, it's a secondary benefit to the overall goal of transitioning to more of that push model rather than the traditional pull.
Thank you, sir. And then I will begin with some general questions. The next question will be, are prototype demonstrations expected in laboratory environments, operational environments, or field exercises? So demonstrations are not a part of this competition, but may be part of the follow-on activities for those companies awarded a SBIR. The context of the demonstration would be determined at that time. The next question is there a pathway for xTech participation into Army programs of records, SBIR opportunities, other transaction authority contracts, or operational pilot programs? The pathway for transition is dependent on the specific xTech competition, and those transition opportunities are outlined in each competition's RFI. For this competition, winners will be eligible to submit a Phase 1 SBIR proposal up to $300,000. So we encourage you all to please read through the RFI if you have not done so already. Next question is, does the Army anticipate opportunities for dual-use commercial technologies that can be adapted for military applications? The xTech program is always looking for technologies with dual-use potential. For this particular competition, we are looking for proposals to develop the internal Army IP sets that are listed in the RFI. Companies should respond with a proposal that develops one of these IPs and the dual-use potential. Please refer to the evaluation criteria and valid eval for more information. What level of Army sponsorship, transition support is provided to winning technologies to help bridge the gap between successful demonstrations? We offer an accelerator program, as mentioned before, providing programming for finalists with supplementary programming reserved for winners. Furthermore, individuals selected for a SBIR award will be paired with a technical point of contact, acting as your subject matter expert or inventor. Should you be awarded a SBIR, you will collaborate with your TPOC for the duration of the period of performance. What characteristics distinguish the most successful xTech submissions in previous competitions? Proposals should provide structured, detailed explanations of their proposed solution while incorporating supporting data, relevant research, and evidence of prior testing or proven performance to establish technical credibility. Additionally, clearly and directly address the specified evaluation criteria, enabling reviewers to efficiently verify how the proposed solution meets each dimension. What is the preferred way to disclose the pending proposal to the program office as Section 2 directs? Please email the disclosure to the xTech mailbox. The next question is, how does the program apply substantially the same tests? Does it turn on the specific technical approach and function, or on the broad end results? Would submitting in this situation put either my eligibility here or my pending proposal at risk? All submissions to the xTech Inversion competition will undergo a comprehensive review to prevent duplication of effort. Proposals must represent unique technology solutions. If an entity's proposed solution is determined to be duplicate of an existing proposal, active contract, or prior award within the Department of Army or a federally funded government entity, the submission will be deemed non-compliant and ruled ineligible for further evaluation or award under this competition. The next question is, does the Army prefer white papers that focus on direct Army transition first, commercial market adoption first, or a dual use path that demonstrates how commercial adoption can reduce costs, increase maturity, and accelerate Army deployment? Please refer to the evaluation criteria listed in the xTech Inversion valid eval sign-up page. Does the xTech Inversion competition allow for supporting combining IPs in one proposal? Only one IP should be submitted for each proposal as outlined in the RFI. And one additional question, for software-focused small businesses, is the Army open to proposals that commercialize one of the Army IP sets by building a complementary software analytical governance sustainment or commercialization layer around the IP, rather than manufacturing the physical device or material itself? So this is your opportunity to showcase your solution. If your solution is focused on one of the IP sets within the RFI, then we encourage you to submit a proposal for consideration. We're looking forward to seeing a range of creative and impactful solutions and discovering how your expertise can contribute to advancing Army initiatives. So now we're going to go into some of our IP set questions. So our first one is going to be for IP set 1, which is fibers loaded with zirconium hydroxide to capture, degrade toxic chemicals. And this question will go to Mr. Matthew Jones. Can zirconium hydroxide material in this topic be used as a coating on a chemical sensor for CWA detection, rather than being incorporated into textiles? Would such a sensor-focused application be considered within scope? Use of the material in our sensor elements will help CWA effectively. Mr. Jones, I pass the floor over to you, sir.
Thanks, Gia. I'm Matt Jones, Technology Transfer Specialist, Environmental Scientist at DevCom, U.S. Army DevCom Chem Bio Center. Our answer to that one is going to be using the zirconium hydroxide as a sensor coating can certainly be considered and discussed. It hasn't really been a topic that we have pursued much at all, definitely not in depth. But the commercial evaluation license would allow for a good in-depth discussion that would possibly involve some proprietary data or methods.
Thank you, sir. And I have another question for you. Will awardees have access to the underlying fabrication methods, technical data, and know-how associated with their zirconium hydroxide technology?
Okay. The commercial evaluation license would involve data directly related to the patent being licensed. Separate underlying fabrication methods, technical data, etc., could possibly discuss under a CRADA, provided there is sufficient benefit to the Army and the Chem Bio Center. Really, everything is open to discussion.
All right, and then I have two additional questions for you, Mr. Jones. During the Phase 1 feasibility effort, it is anticipated that the Army could provide samples of zirconium material or fibers containing the material for evaluation and integration into our proposed applications. Having samples from the Army will significantly speed up the development and make decisions for go, no-go to Phase 2 effectively.
So if a sample, the answer to that is if a sample of sufficient amount exists to allow for being provided under the commercial evaluation license, this could definitely be discussed and possibly included in the evaluation license terms. Another possibility for that is a CRADA that would allow for fabrication of sufficient material quantity. That could require cost reimbursement, again, depending on the documented benefit to the Army and Chemical Biological Center.
Ms. Jamie Wilson, the floor is yours.
Thanks so much. And guys, I just want to make a distinction between the competition and the follow-on opportunities. So the competition, just please make sure that you're reading the RFI. The competition has prize money associated with it and the opportunity then to apply for an SBIR as a follow-on. Anything beyond that is outside of the scope of the competition, and so you're not guaranteed anything by participating or even winning this competition other than the prizes as laid out in the RFI. But it's good to know that there are opportunities potentially afterwards. And as you participate in the competition, those that are selected as winners, there is an accelerator program where you'll get to learn about more opportunities that may be out there for follow-on. But I just want to make sure that you guys understand that what is in the RFI, which is posted, you can download it from our webpage, is what the competition is what is part of this competition, and other opportunities are just that, other opportunities that are outside the competition. Thanks, Gia.
Thank you, Ms. Wilson. And for everyone's awareness, Ms. Jamie Wilson is the xTech Innovation Lead. All right, Mr. Jones, one final question, and this is for IP Set 4, Advanced Sealing Interface Surveillance Technology. Would the Army view predictive maintenance, cost to readiness analysis, maintenance, and audit-ready sustainment reporting as valuable commercialization extensions of the underlying sensor diagnostic technology?
Okay, as a research lab, CBC would not perform these kinds of analysis at our R&D level. When these transition to a program of record, that's when it would initiate to start to look at all those factors. But I would say a patent licensing partner may choose to do some of these commercialization background as part of their business development decision process. But to do analysis, stuff like that, it would be more on the maintenance side, some of our further down the road toward making something a program of record. Over.
Thank you, Mr. Jones. All right, our next set of questions will be for IP Set 11, Dual Coil Inductive Energy Generator. And I will ask Dr. Ryan Knight to answer these questions. The first one is, what were the original design G-force parameters for the shear disc retainer mechanism, and has any variant been tested at a lower acceleration thresholds in the 8-50G range?
Yes, thanks for having the questions for me. So I wanted to give a little bit of background. So the IP set 11, the patent was dedicated towards solving an setback generator energy problems for munitions. So setback generators are used in explosive munitions for primarily two reasons. One is that so the munition doesn't have to have a stored energy source. You don't want to be walking around carrying munition that has live energy that could cause it to detonate. And then two is the rapid increase. You can use the gun launch setback and rapidly increase energy so that when the round exits the muzzle, it's energized and ready to begin its mission. To answer the specifics of the question, this was designed for the M203 and the Mark 19 40mm grenade platform. So there's two different shear discs used, which or shear disc or rupture discs, which are used for the respective gun launch acceleration platforms. So nothing below 11,000 Gs was tested, and typically the pulse duration was around a millisecond. The magnet, it's in a non-displaced position. It's tightly held so that if the round's dropped, there's no energy that's created. So 50 Gs is definitely not enough static acceleration to break the pull force of the magnet, and really to get the magnet to move, you need around 1,200 Gs. Over.
Thank you, sir. The next question for you is, what was the measured power output in the laboratory testing? Peak, average, and minimum? And at what acceleration profile was the output measured?
So a lot of the laboratory testing was dedicated towards the M203 platform, which is a grenade launcher that attaches to an M16 rifle. So in this case, it's a lower velocity, so there's less amount of muzzle velocity, and therefore there's less energy to kind of harvest. So it's it's a harder platform to gain more energy. So our customer required that we produce 9 millijoules of energy. So we ended up using a 30 gauge bobbin wire that produced roughly 13.7 volts on a 120 microfarad capacitor bank. And this accounts for the permittivity change that you get whenever you put voltage on a capacitor. And so there was other tests where we use different gauges, and you can gain more energy at the expense of having higher voltages. So it just depends on what the particular customer requirement is. And then for the higher velocity Mark 19 platform, we've estimated that anywhere between 30 to 60 millijoules can be generated with this system. Over.
All right, and the next question for you is, what is the output voltage and current profile of the generator? AC frequency, peak voltage, and internal resistance of the coil.
Yeah, so for the customer requirements, as I mentioned in the previous question, there was a 13.7 volts would charge 120 microfarad capacitor, and the power curve basically kind of mimicked the gun launch setback acceleration profile, and the coil winding resistance was roughly 0.7 ohms.
All right, 2 additional questions for you, Dr. Knight. What materials comprise the cylindrical enclosure, magnet, and coils? Specifically, whether any ferromagnetic materials are present that would interact with a brass or aluminum housing.
Yeah, so for the housing, the magnetic housing, we used Cartech stainless steel 430F. There's several different material reasons why we picked that. And then for the magnet, we used a neodymium D42B-N52. And the coil bobbin is made out of plastic. We did not use any brass or aluminum. Over.
All right, and then the final question for you. Has the harvester been tested in any continuous low G oscillation environment, vibration table, pendulum, or wrist-worn prototype, as opposed to single event setback testing?
Yeah, so this was for single event setback testing, where we need to kind of make sure that the magnet is is tightly confined and not displacing, so that the system doesn't energize during vibration or dropping, and keeping the soldier safe. And then, so like the opportunity space here, if I guess I can bring that up, is that potentially if you can generate more power out of setback generators, you could replace reserve batteries, which are batteries that have that isolate the electrolyte from the anode and cathode, and they produce more power, but at the expense of rise time, and also they're just more expensive. So if a setback generator can harvest more energy, then therefore it could be potentially replacing these reserve batteries, and could push towards new applications like counter UAS. Over.
Thank you, sir. We'll next go into IP set 12, which is voltage step up converter circuits for low input voltages. We will now ask Mr. Damian Ursioli to answer this question, and for Dr. Melissa Nair, if she would like to add any additional information as an expert for this IP set. So the question is, how should the white paper address that the topics are very light on technical specs? Will there be an opportunity to narrow the technical requirements in the next phase? Should we define the missing specs ourselves based on technical feasibility, ease of commercialization, or other criteria? What about proposing an open architecture that can adapt to applications and specs that will be defined in the future? Over to you, sir.
So, thank you, Damian Ursioli, Army Research Lab, electronics engineer. The patent was written as broad scope to cover several other configurations of the topology, so that may be why the generalizations. But this technology was developed for thermoelectric generator wearable devices on skin at small areas, so like 30 millimeters by 30 millimeter contact area to the skin of a thermoelectric generator. With a device size that's like 2.5 inches by less than 2 inches on that. So, we have another document that's public releasable that I passed on to the xTech committee that hopefully can share that. It's got example specifications more detailed, but this runs, we can get into the, I guess you'll get into the more specific questions. Is that concise enough?
Yes, I will ask the additional questions as well. And just want to confirm, Dr. Nair, did you want to add anything additional?
Yes, so Dr. Melissa Nair, research physical scientist from USA's ERDEC. I would just add that white papers should treat missing technical specifications as part of the problem and clearly state justified engineering assumptions within the known operating envelope, such as ultra-low input voltage, power levels, efficiency, and intended application. So open architecture approaches are acceptable, but they must still define clear performance and physical boundaries so feasibility and transition potential can be assessed.
Thank you, ma'am. The next question for you both is, has the converter been tested in combination with IP set 11, dual coil inductive energy generator, as an integrated power chain, or have they only been validated independently?
No, this was not developed in conjunction with 11 and IP set 11 and has not been tested with it. Totally separate development efforts.
All right. The next question is, what is the minimum input voltage the converter has been validated to step up from, and what is the output voltage range?
Yeah, so the converter will start oscillating. It'll self-start at less than 20 millivolts. So by 20 millivolts at room temperature, the converter will start up. That's for a wearable system. So that's on body temperature, skin temperature of a person at room temperature. I'm sorry, that's what a TEG would provide. So 20 millivolts actually to the converter to start up, and providing up to 2.5 volts. In our case, this is about a 100 to 1, over 100 to 1 step up ratio. So If you have a higher input voltage, I think one of the questions was 500 millivolts or something, which is 25 times higher than 20 millivolts I just talked about. If you have input voltages that are that high, you can get to much higher output voltages. But this was designed for wearable electronics with, like 2.5 volt input. And at those voltages, so for instance, 20 millivolts for an output of over 2 volts, so greater than 101 step up, 35 millivolts input to 2.5 volts output at over 400 microwatts was demonstrated at 58% efficient. And we reached over 60% efficient for peak efficiencies and other tests. Over.
Thank you. Dr. Nair, did you want to add anything additional?
Yeah, I mean, I think it was clear, but I can add that the expected input is ultra-low voltage energy harvesting, generally in the tens of millivolts up to approximately, I think, 1 volt range, with emphasis on reliable operation below half a volt, consistent with demonstrated systems such as Eclipse. So the desired output is typically regulated at 1.8 volts and or 3.3 volts to support low power sensing, processing, and communication loads. Over.
Thank you. And one last additional question for IP set 12. What is the physical form factor of the converter circuit? Rigid PCB, flexible substrate, or bare die? And what are its dimensions?
Sure. Yeah, we demonstrated on rigid PCB, but it can be, there's nothing particular about that. It can be done on other substrates. The size for the active, part of this converter without load was 0.85 inches by 0.4 inches. So it's 0.34 square inches. So pretty small, about the size of a dime. That was for double-sided, so components on both sides in that design. And the volume for height of components included would have been 0.1 cubic inches.
All right, well, thank you, ma'am and sir. Our next question includes several IP sets, so I'm actually going to open the floor to all the subject matter experts and innovators on the call to answer this question. So for IP sets involving sensors, diagnostics, predictive maintenance, power monitoring, water systems, or deployable infrastructure, how should applicants address the operational sustainment model, including life cycle costs, readiness impact, maintenance forecasting, deployment economics, and audit-ready accountability? Subject matter experts and inventors, you can simply come off of mute to answer this question.
This is John Brame from the Corps of Engineers. I'll go ahead and speak to some of it. Our colleague previously mentioned that a lot of these topics are really hammered home later in the acquisition process as a sensor might move towards a program of record. I will say it's important from just kind of the business dynamics function of the competition that you understand what these topics are for your system and provide some, indication of what they add in terms of cost, readiness, maintenance, et cetera. Also, just in terms of cost, if things can be open architecture, plug and play rather than black box, that is very much encouraged. Over.
Thank you, sir. Do any of our other subject matter experts or inventors would like to answer this question as well?
Dr. Meysanallar here from USAID's ORDEC. For IP sets 8 and 12, I think I can try to give a general answer. Applicants can address life cycle cost, reliability, maintenance burden, deployment economics, readiness impact, and where applicable, data integrity and auditability. So I think the emphasis could be on reducing long-term sustainment burdens, such as eliminating or minimizing battery replacement and maintenance cycles, while improving operational continuity. So quantitative estimates should be included where available. Thank you.
Thank you. And if anyone else would like to answer this question? All right, we'll move to the next question regarding IPs, and I will ask Mr. Jason Crawley to answer these next several questions. How should applicants handle IP rights when combining Army-owned background IP with participant-developed software, data models, algorithms, dashboards, workflows, or commercialization methods?
Yeah, Jason Curley, Army Research Lab Tech Transfer Office. So there is a licensing process that would be followed. That will be covered later in the finalized accelerator, I believe. But there would need to be a patent license application submitted just to cover that in more detail. That's all I have to say on that.
Thank you, sir. And the next question for you, can you please explain how the U.S. Army patent is shared license to the small business, including terms of license costs? Additionally, asking, can the small business license acquire the patent outside of the xTech Inversion program?
So they can certainly apply for licensing a patent outside of the program. If you're interested, definitely get in touch with the Tech Transfer Office for the Responsible Laboratory. So again, I think we're going to cover more details on the application process later on during the accelerator, but you definitely would need to detail your intent for the IP and provide a detailed commercialization plan.
All right, and then the last question from Mr. Crawley, or if Mr. Schmel is on the call. What intellectual property rights will participating companies retain, and what rights does the Army expect regarding the future use, licensing, or deployment of the submitted technologies?
Again, this really depends on what the intent of the company would be. I mean, it's just a very general question. So again, I just referred to the patent license application process. Again, I definitely encourage anybody to reach out to the right Tech Transfer Office POCs, depending on the IP sets, to discuss that further.
Thank you, sir. And for our final question, which is regarding the SBIR program, I'm going to pass this question over to Ms. Amanda Osborne. The question is, for the Phase 1 Army SBIR under the topic for this competition, does the Phase 1 proof of concept need to focus nearly on the IP set itself, or may it include integrating the IP set into the applicant's host platforms as the demonstration?
Good afternoon. This is Amanda Osborne. I am with the Army SBIR office. I would recommend the company do what makes the most sense for them, that either approach is feasible.
Thank you, ma'am. Next slide. And that will end our Q&A portion of this session. If you have any questions after the session, please feel free to reach out to the xTech team email address that is listed on the screen. And if you need any support with Valid Eval as you create your profile and submit your proposal, please reach out to the Valid Eval team at support@valid.eval.com. Thank you, everyone, for joining us today. This concludes the xTech Inversion informational webinar. And before everyone departs, I would like to pass the floor over to Ms. Jamie Wilson.
Thank you, team. And thank you, everybody who joined us today. We really are looking forward to this. This is a different competition than one we've done in the past, so we're excited about it. I do want to point out the SBIR website there. These questions and answers will be posted on DSIP, so we encourage you to visit the SBIR site, create a DSIP account, and that way you'll be able to refer back to these questions and answers, as well as any other questions and answers that may arise. We want to make sure that everybody has access to the same information, and just to protect the integrity of the competition. So I want to make sure that you guys are tracking that upper right website for www.dodcybersitter.mil, as well as the lower left xTech email, which is where you can reach out to us directly and get support. Finally, if you have not downloaded the RFI, please visit the xTech website, xtech.army.mil. Click on xTech Inversions card, and then you will see a button that says Download Full RFI in the upper right. Please do that and consult it. It really lays out in detail what this competition will look like, the evaluation criteria, what you're eligible for, the process, as well as the dates in general. So again, we appreciate you joining us, and we look forward to a very successful competition. Thank you.
Thank you, Jamie. As Jamie just said, thank you everyone for joining us today. Please enjoy the remainder of your day. Goodbye.